Okay, so welcome to the chapter on similarity and dilations. The first thing we're going to talk about is scale drawings and similarity. And as you can see from this smartphone, somebody went into their phone and they clicked on the image and they zoomed in. So this is a basic example of an ability to scale or enlarge or reduce a picture based on your phone. Now, we're going to take a look at this packet, so please make sure you have it in front of you. The next one is a bicycle. Using this picture of a bicycle, which of the images below appear to be a well-scaled image of the original, and why? This one looks distorted. It looks like it was stretched out this way. This one was distorted because it was elongated or made taller. And this one right here looks as though it would be the best well image of the original, and that is because the bicycles look the same shape, they're just a different size. So if we look at this one and this one, the bicycles are the same shape, they're just a little bit, this one is just a little bit smaller. So keep that in mind, please, while you look at this page. Please make sure you write this down. Moving on to the next page. It says you will need a compass and a straight edge. Please make sure you have a compass and a straight edge. If you do not have either of those, pause the video so you can go and get one. Now it says create a scale drawing of triangle ABC with a scale factor of 2. So when I look at this triangle right here, what I need to do is I need to extend AB so that it is longer than the original. And I also want to extend AC so that it is longer than the original. Now, an interesting thing here is if I'm going to use a compass to make a scale drawing with a factor of 2, what I'm going to do is I'm going to measure how big it is from A to B. So notice you open and close your compass, and I'm going to make a little tick mark there. Now, I want it to be twice as long, so along this line, I'm going to poke at B and make another tick mark. Now, this is going to be my B prime. This is going to be A and A prime. I'm also going to measure from A to C. So you want to open up your compass so that it measures to AC. Show a little tiny mark there to show that you measured that opening or that length. And then we're going to poke at C and make another tick mark up here. This is in fact going to be my C prime. And then I'm going to connect the two. So you want to connect B prime with C prime. And once done, you will have a triangle, a new triangle, that is in fact similar to the original one. So triangle ABC is similar to triangle A prime B prime C prime. So notice that it's just twice the length. Okay. Now the questions on the bottom, it says, what is true about the sides of a well-scaled drawing? And the sides are in proportion. And then it says what is true about the angles of a well-scaled drawing. You should already know this, but just in case, they are equal in measure or congruent. And it says the constant of proportionality by which all the lengths are scaled is called the scale factor. So we've talked about that in class before. Please make sure you write those down. Okay, moving on to the next page. We're looking at page 3. It says you're going to create a scale drawing of triangle DEF with a scale factor of R equals 3. So instead of making the segments twice as long, we're going to now make them 3 times as long. We're going to use scale using different angles to see what the end result is. Right now we're just going to do the first one using angle E. So from angle E, which you should have on your paper, you're going to extend the line segment ED. Please make sure you line up the straight edge correctly. And we want to make sure that it's pretty long. We're also going to extend EF. Now we also want to make sure that this line segment that you extended is at least 3 times as long as the original. Because remember, our scale factor is now 3. I'm going to measure from D to E with my compass. So I'm going to make a little tick mark to show that I measured it. And then from here I'm going to do another one. And then now, because the scale factor is 3 times, I'm going to make a third tick mark here. So notice that if this is E and it's going to be E prime. This point all the way up here is going to be my D prime. This piece right here is 3 times as long as the original ED. I'm going to do the same exact thing for EF. So remember, we're going to poke at E, and then we're going to open up our compass so that it measures to F. Make a little tick mark to show that you measured it. And then we're going to make 2 more tick marks, one from here, and then another one. Notice I did this on purpose, that this line segment was not long enough, so you definitely need to extend it even more so that it is in fact going to cross. This point up here is my F prime. Now, just like the last example, if I connected D prime with F prime, then the big triangle, this big one here, which is triangle D prime, E prime, F prime, is going to be similar to triangle DEF. So let's just write that right here. Triangle DEF is similar to triangle D prime, E prime, F prime. Okay, and in this case it was a scale factor of 3, and the center of dilation in this case was at point E. So we can write that down. Center of dilation at point E. So keep in mind that this example, what it was trying to show you is that if we centered the dilation at F, my triangle would actually come this way, and I would have a different triangle. So clearly the center of dilation makes a big difference on where the triangle is going to wind up. Okay, and now we're just going to the last page on the back. It's page 4. So it says you will need a compass and a straight edge. Please make sure you have a compass and a straight edge, otherwise we're going to have problems. Now it says create a scale drawing with a scale factor of r equals a half. So already you should know that the triangle is going to be half the size, so the corresponding sides are going to be in proportion, or in a proportion of 1 to 2. We want this relatively big triangle to get smaller and to shrink. In order to do that, the best thing to do would be to find the midpoints of YZ and the midpoints of XY. Now to find a midpoint, we're going to do what we call the perpendicular bisector. So we're going to open up to 3/4 of the way. We're going to make a big semicircle. We're going to poke at X, same arc length, and we're going to make another arc. We are going to connect this with a dotted line. The reason I'm connecting it with a dotted line is because this point right here is going to be my X prime. Think about that for a second. So if this is one distance, this is going to be half the distance. In this case, I've decided to do this scale drawing centered around Y. You could have chosen to center it around X or Z. So this is also going to be Y prime. And now I'm going to find the midpoint of YZ. So remember, your compass needs to be open to about 3/4 of the way. You're going to make a big arc. Then you're going to poke at Y. You're going to make another arc. I'm going to go back to this one and make my arc a little bit longer so that they in fact cross. I'm going to make a dotted line. And again, that's the perpendicular bisector. But this is my Z prime. And then all I have to do is connect X prime with Z prime. And with Y prime, it makes a new triangle. So I have this little triangle up here, and it is similar to the big triangle here. Notice again that Y and Y prime are the same, and in all of the examples I've made 2 sides and the included angle. The angle is the same, the 2 sides are in proportion. So I'm going to write triangle XYZ is similar to triangle X prime, Y prime, Z prime. Okay, that's about it. Thanks, and I'll see you tomorrow.